Hello everyone, and welcome to this talk for ENG 730, Advanced Timber Manufacturing and Fabrication. So in this talk, we're looking at prefabrication options for the intended building. That's the building that we want to build and that we're designing. So in this talk, we're looking first of all at prefabrication, what it means, approaches to prefabrication, item performance, and then item complexity. So we're talking really about advanced manufacturing and fabrication, but in this context, it's really can be quite synonymous with building prefabrication. So if we're looking in terms of context, a building that is prefabricated may have advanced manufacturing and fabrication in it, but it might just be manufactured and fabricated. So if we're talking about advanced, we're obviously talking about a level above and beyond what we would normally expect to see in standard cottage construction, which is something like a frame and truss operation. We're moving beyond that into a more sophisticated way of approaching manufacture and fabrication, and that's usually in prefabricated components that are designed to be relatively high performance compared to our standard frame and truss arrangements. So if we look at what prefabrication is first. So prefabrication is the design and on-site manufacture of a project-specific element, component or system used to build a structure, or it may be the whole structure. So in this case, we've got a small building that's been designed to be lifted in and lifted out of a particular site, and it's obviously a prefabricated component. It wasn't made there, it was brought in. And when we talk about prefabrication, then there is three major types of approaches that we can deploy in prefabrication. The first is a volumetric module, and that's a three-dimensional object that we can make somewhere else and bring in. The next is a panel, or a two-dimensional object, or a stick, which we can think of as a one-dimensional object. So if we look at what each one of those might look like, a prefabricated volumetric modules are three-dimensional components designed and assembled as the whole or segments of a building. They're components to be stacked one on top of another, and they can be serviced or structural cores or other complex components. So they could be an envelope component, they could be a stair component. What we're seeing here in this photograph is that these are university accommodation modules. So each one of those is a student apartment. It's manufactured off-site, been brought to site, and then it's being stacked one on top of the other. They're load-bearing objects to form the basis of the building. And they're completely finished. So the services are all in place, the plumbing's in place, the tiling and joinery are all in. So volumetric models can be whole rooms or specialist areas, and they're suited to projects that have multiples of similar service rooms, such as hotels or apartment buildings, where compact and highly serviced spaces or complex specialist areas have to be provided. This may be facades or stair units, or where we've got amenity units or service cores in office buildings, houses or apartments. They're also highly useful in areas where supply of skilled trades is low. So if we know we've got an area where plumbers are hard to come by or tilers are hard to come by, then we want to prefabricate those components where those skills are available, and then we can reduce the number of trades we need on a site. Panels include prefabricated wall frames, pre-assembled wall frames, nail plate and other floor and roof trusses, floor consets, stress skin panels, massive timber panels such as CLT, and all of these things which are effectively a two-dimensional object if we're considering them that way. So we've got, in that photograph, we can see we've got a floor cassette. So it's a panel that's been assembled somewhere else. It's got particular structural capacity, satisfies particular performance requirements, and it's brought into place and it's sat in the building where it's required. So panels can be used in timber-rich buildings of almost any size. Prefabricated wall frames and nail plate trusses are very, very common in low and mid-rise residential and commercial buildings. Floor cassettes and clad wall frames are well suited for similar sizes and classes of buildings, so that's low to mid-rise residential and commercial buildings. So mid-rise, we're talking up to 6-8 stories. And massive timber panel systems are used for buildings to 10 stories and beyond. So there's various ways in which these items can be manufactured, whether they're satisfying a residential function, or they're in a major multi-story building. And the last one we can think of is sticks. So sticks are timber elements that are made or cut to size and prepared for the projects. They might be beams, they might be columns, they might be a whole range of other things as well. Sticks are optimised nail plate, and nail plate elements are widely used in spanning floor and roof elements of low and mid-rise buildings. They limit site work, they reduce material wastage, and they improve economy. So they're obviously not an advanced manufactured item in themselves, but when they're combined with a whole range of others and services, they can go there. So there's more complex elements can form the rafters, beams, and post and arch elements in major roof and wall systems and in frame systems of multi-storey buildings. If we're looking at these things, our three-dimensional modules, our 2D panels, our 1D stick, we can think of them also in terms of the levels of performance that they're going to provide. So how many different performance requirements is the object going to satisfy? So if we're making a module, for example, we could just make it as a structural item that gets delivered to site. We could make it so that it includes envelope, or that it starts to include a whole range of different services as well. So in each of those cases, we're satisfying more and more and more performance requirements. So we can move from a simple element all the way through to a complex one. So in ways in which we can describe them then, a high performance prefabricated element might satisfy multiple performance requirements such as structural, fire, envelope, insulation and services. A mid-level one might satisfy several performance requirements such as a structural requirement and insulation, etc. And our basic ones might satisfy merely one performance requirements in a relatively simple configuration. So obviously, if we're looking at this wall frame or that floor system that the wall frame's on, they're a relatively simple prefabricated component. And they satisfy a single performance requirement, which is structure. If we then start to think of those in a more complex manner, where their objects is handling more performance requirements, we can then start to consider things like this. So these are high performance wall panels. They satisfy structural, thermal, water exclusion and cladding requirements in a panel that then is manufactured in the factory. It's manufactured to a particular size. It includes windows and doors. It includes all your cladding. It includes the basic servicing, electrics, etc. And then it's brought to site. And these things then assemble in a precise manner to give you an enclosed building very quickly. So this is obviously a relatively high performance panel, even though the shape of the panel and its form is relatively simple. They're a flat object. This is a high performance volumetric module. So this is the inside of a module. The module itself is about 4.1 meters across or at the outside. So it's about 3.85, 3.9 inside. They're completely serviced, they're lined, the joinery's in, the tiling's in, the plumbing works, and all the services are led back to a single duct, which then allow for all of them to be connected up without anyone actually coming into the module before the building's complete. So this is a high performance module. It does satisfies many performance requirements. The walls that you can see there on the right hand side have fire resistance, they have insulation, they have sound separation. So all of these performance requirements are satisfied in the unit itself. There's then a level of complexity that we can consider. So we've had 3 different types of modules. We've got our volumetric, our panels, our walls. We can then see that each of those 3 can satisfy a few or many performance requirements, but there's then something that comes in with the complexity of the shape or the configuration. That is also something where then we need to consider. So if we have a high complexity unit, these can be a highly complex shape that then potentially satisfy multiple performance requirements. We can have a mid-complexity shape where we've got a complex shape with potentially several performance requirements. And we can have a basic complexity where we've got a relatively flat and simple shape, maybe rectilinear. It satisfies one or a few performance requirements. It could be something that has relatively significant satisfies relatively significant performance requirements and still be relatively simple in shape, and that would be a mid-complexity unit. So here's an example of basic complexity. So this is a floor cassette. This photograph was supplied by colleagues at Multinail, but the other truss and frame manufacturers would all have very similar solutions. Here you've got nail-plated trusses which are acting as joined together to form a cassette, which is then being lifted in between lines of support. It's quite a relatively simple prefabricated object. It's relatively flat in terms of its shape, so it's quite an easy thing to understand. Here's a mid-complexity stair module. So this is a stair, CLT stair that's been assembled off-site. It's come to site as a unit. It's then being lifted into place. So it's obviously prefabricated because it was made somewhere else. It satisfies a series of structural, functional and appearance requirements because it's in a major public building. It will be seen. There's a lot of services that may be integrated and it forms some structural function as well. So it's a mid-complexity stair module. It satisfies those ranges of performance requirements, and it's not just a simple shape. Here's a complex unit. This photograph was provided by a colleague in Switzerland, and this is a quite complex experimental roof module that was manufactured. This is one of a series of modules, and each piece of timber in there has had to be cut to a particular shape, nailed in a particular manner, and it's all been done by robots and machines. And because it's been done by robots and machines, and because it's an experimental unit, they're looking for different ways in which the module can be assembled to demonstrate capability. So it's an experimental item, and it's obviously very complex in the way in which all of it's been assembled. It will then be put into part of a roof structure, and it's quite a significant span roof structure. So this is a complex unit, as are these. They're complex units. So these is a photograph of the envelope going on to the Swatch building in Switzerland. Again, this is provided by a Swiss colleague who had access to these photographs. And we can see there that that envelope is made up of very, very complex glue laminated elements, which all got to fit together and interlock. Now, manufacturing these is quite a complicated process, and therefore these items, which are effectively a stick in the terminology that we've been using in this talk, they're a highly complex prefabricated stick because they move or they change direction across the length of the stick. They've all been machined so that everything can go together really carefully and nicely. So that's quite a complex process, and they're going obviously into quite a sophisticated design. So while we've got a simple stick, it's actually a very, very sophisticated, highly complex shaped stick, and we can think of our prefabrication as either being very simple, very mid-complexity, or in this case, high complexity. So in summary of this talk, advanced manufacturing and fabrication is synonymous with buildings prefabrication. If we want to make it advanced, it's got to be a bit better than what we can get as an everyday solution at the moment. So prefabrication is the design and off-site manufacture of a project-specific element or a component or a system used to build a structure. It can be the whole of a structure. Oftentimes, it's a major component of a structure which is then brought in. Prefabricated items can be grouped as either volumetric modules, panels, or sticks. And prefabricated items can vary significantly in their performance and their complexity levels. So they can satisfy many performance requirements or just a few, or they can be reasonably simply shaped, or they can be highly complex ones. In each of these ways, we can then consider how we can prefabricate our components by using these concepts to sort of define the things that we want it to do and realize the potential in that we can, through prefabrication, cover all of these different solution sets. Thank you. I hope that was of interest.